Hello, in this video I'm going to show you how to construct a decision tree. Decision tree learning is one of the means by which we can extract the knowledge and represent it in the form of a tree for any given data set. From this decision tree, we can even generate the rules by traveling from the root node till the leaf node. And for example, if you see in this particular small figure, given a number of examples or number of instances of your data set, I'm going to construct a hierarchical tree where this vowel shape corresponds to the nodes and these lines are corresponding to the edges. And what goes into the node is nothing but the attributes, input attributes, and what goes into the edges are nothing but the values of the input attributes. And as you travel down the tree, it can take any number of levels. Shorter tree will be more compact, and as we travel down the tree, the leaf nodes are nothing but the output attribute. For example, this is the weather data set where you are having 4 input attributes such as outlook, temperature, humidity and windy, and play is the output attribute. And each one of these input attributes are taking the nominal values, and for example in the case of the outlook, it takes the nominal values of sunny, overcast and rainy. Similarly, all the other input attributes also takes a number of nominal values. And play is the output attribute which takes the nominal values of yes and no. When I construct a decision tree for this shown weather data set, the tree will be like this, where if I can write a rule from this decision tree, I will be writing as if outlook equal to sunny and humidity equal to normal, then play equal to yes. So this edge forms one rule. So the number of rules in this particular decision tree is equal to 5, where you can see there are 5 leaf nodes. So when I construct a decision tree, I can read out the representations in the form of classification rule from the decision tree. How to construct a decision tree? This is also called as divide and conquer approach. It is a top-down approach. I need to find out which should come as the root node, which attribute should come as the root node and then the subsequent node. And I need to derive all the levels of the tree until I reaches the leaf node. For example, I have 4 input attributes in the given data set. So I'm going to find out which attribute is going to take the place of the root. In order to do that, I am trying to extract some information from the input data set. For example, outlook is one of the input attributes and it takes the nominal values of sunny or overcast and rainy. What are these boxes and what are these S and No's are nothing but the related output attribute such as play. So if my outlook equal to sunny, there are 5 instances which satisfies this condition, and the corresponding output attribute play equal to yes and no. There are 2 yeses and 3 no's in this 5 instances. And similarly here, if my outlook equal to overcast, there are 4 instances which satisfies this condition, and all the 4 instances says play equal to yes. And similarly in the case of rainy. So now I am deriving some information from the input data set. Then I'm going to find out some information such as entropy and information gain in order to identify which is going to be the best node or the purest node. I need to find out the node which is going to give me a maximum information, for which I am going to calculate information gain. If my information gain is very high, it means that it has got a lot of information. How to calculate the entropy and some more details about the entropy. Entropy is nothing but the amount of information that it contains. If my set of instances are not homogeneous and the class attribute, that is play equal to yes and no or equally likely available, or the percentage of play equal to yes and no are 50-50 percentage or equally likely, in that particular case my entropy is going to be very high. But if my entropy is going to be zero if my set of instances are going to land up in a homogeneous class, that is play equal to yes or play equal to no. It will drop down to one of the classes. So how to calculate this entropy? As I already showed you how to arrive at this information, what I have written down is nothing but this information is having 2 S's and 3 no's of play, and here it is having 4 S's and 0 no's, and here it is having 3 S's and 2 no's. So how am I calculating the entropy? For example, if outlook equal to sunny, the formula for calculating the entropy is given in this particular slide. It is 2 by 5. What is 2 by 5? Is nothing but I have 5 instances. So that's why my denominator is 5. When I say 2 by 5, it means I have 2 play equal to yes out of 5 and I have 3 no's out of 5. So the formula is going to be minus 2 by 5 log of 2 by 5 minus 3 by 5 log of 3 by 5. When I do this particular calculation, it is going to be 0.971. This logarithm is not logarithmic of 10, it is logarithmic of 2. So in order to do this particular calculation in a much simpler way, how I can do is minus 2 by 5 into log to the base 10 of 2 by 5 divided by log of 2. Please remember, if I want to calculate for this log of base 2, I can calculate it as log to the base 10 of 2 by 5 divided by log of 2. So when I calculate this particular calculation, I will be getting 0.971. And similarly, I am calculating it for overcast and calculating it for rainy. You can see the values that it is giving. And you should be wondering why it is having 0. It is well understood from the previous diagram. The entropy is going to be 0 if the set of instances falls into one of the classes or if it is a homogeneous class. Here in the case of the overcast, I have 4 instances where it says play equal to yes and none of the instances says play equal to no. So it is a homogeneous class of play equal to yes. So you have an entropy of 0 value. Now, this is the same calculation that I have showed in the previous slide. Now, I am going to calculate the average of all the entropy values of all the 3 nominal values of outlook. There are 3 nominal values. I have calculated the entropy for info 2, 3, 4, 0 and 3, 2. I have 3 entropy values. Now I am going to calculate the average of all these 3 values. How to calculate? There are 5 instances out of 14 with the entropy value of 0.971. That is this value. Out of 4 instances out of 14 with an entropy value of 0 and 5 instances out of 14 with the entropy value of 0.971. So this is going to be the average entropy value for all the 14 instances of your data set. After calculating this entropy, I am going to calculate the information gain. How to calculate the information gain? The information gain is equal to the information that flows into the node and the information that flows out of the node. That is the information before splitting and information after splitting. Whatever we have calculated is information after splitting. I mean, when I assume that I am splitting this data set and whatever the information gain that I am going to get on these 3 edges is what I calculated. But I need to calculate what is the information before splitting. The number of instances that comes to the outlook node is 14 instances, out of which 9 instances says play equal to yes and 5 instances says play equal to no. So I need to find out the entropy of 9, 5, which is the entropy calculation before splitting. So that has yielded a value of 0.940. And we already calculated the average entropy after splitting, which is 0.693, and it's going to be 0.247 bits. And this is only with respect to the outlook attribute. The same pattern I need to follow to find out the information gain for the temperature, humidity, and windy, and these are the values. Out of which the one that I'm going to pick, the node which has the highest information gain. So I'm going to pick outlook as the root node, which has yielded a very high information gain. So this is my partial decision tree. Outlook took the place of the root node. Now there are 3 edges with sunny, with overcast, and rainy. Now it is my responsibility to find out the next level of nodes. So in this particular place, if my outlook equal to sunny, then I am going to come up with another node, suitable node. I am going to find out which attribute is going to take this particular place. So I am left with 3 input attributes. One is temperature, humidity, and windy. So I need to do the same calculation of entropy and information gain, and I need to find out which has got the very high information. So here the values are given, and humidity has given a very highest value. So the next attribute which is going to take the next level of the decision tree is nothing but the humidity. One point that we need to note over here, for example, there is a calculation that is shown for temperature. For this particular portion, the information has been shown. The information gain is 0.571, which is written over here. One important point over here is how to calculate the gain. I've calculated the entropy for all the 3 values, that is temperature equal to hot, temperature equal to mild, and temperature equal to cool. And I've calculated the average entropy values also. But how to calculate the entropy before splitting? Unlike the previous case where you have used the entropy calculation before splitting as info of 9, 5, which is equivalent to the 14 instances with the play equal to yes 9 instances with play equal to no 5 instances, which are the original data set. But in the next level calculation, I'm not going to use 14 instances. I'm going to use the number of instances that flows through this edge. Through this edge, only 5 instances are flowing. And this 5 instances says 2 of them are play equal to yes and 3 of them are play equal to no. So the information that I'm going to calculate before splitting is info of 2, 3. That is going to be 0.971. So 0.971 minus this average entropy, which is 0.4. So it is going to be 0.571. This is a very important point that we need to remember while calculating the subsequent levels apart from the root node, where the information before splitting depends on the number of instances that flows from the previous node to the next subsequent level node. So when you do this calculation, your final decision tree, it's going to be like this. As you can see here, it will not consider all the attributes, and it will try to find out only the representative attributes to form the tree. And this is the final decision tree. Hope you understood the calculation.